We're going to learn how to estimate population parameter using confidence interval. Confidence intervals help us to capture the true population parameter that can be mean or proportion or any other value. We need to do a little bit of calculation, and eventually we have to use our calculator to feel comfortable about confidence intervals. First, we start by calculating confidence intervals for population proportion. Let us start by writing a definition. The point estimate for P, or population proportion, is given by the proportion of successes in a sample. It's denoted by P hat, which is defined as X divided by N. X is the number of successes in your experiment, and N is the total number of people who participated in that experiment. The symbols P hat and Q hat are read as P hat and Q hat. Q hat is basically 1 minus P hat. The definition of interval estimate. An interval estimate is an interval or range of values used to estimate a population parameter. Well, we need more than that. We know how to find the point estimate. We know the definition of interval estimate, but how do we construct that from scratch? We need more definition. We need more terminology. For example, what is a level of confidence C? Level of confidence C is the probability that the interval estimate contains the population parameter, assuming that the estimation process is repeated a large number of times. Okay, how do we find the level of confidence? When we are talking about level of confidence, the level of confidence is basically this shaded area. 100% of the area minus the shaded area gives you the yellow area. In general, if C is equal to 90%, your C is 90% of the area, which is this blue region. So C is nothing but the blue region down here. 1 minus C is 100% of the area, minus 90% or 10%. 10% to the left, 10% to the right. Now, 10% divided by 2 is 5%. On the right-hand side, you also have 5%. If you use inverse norm to calculate this ZC or Z values, on the left-hand side, it's going to be negative 1.645. On the right, it's going to be positive 1.645. Eventually, you're going to use your calculator to find these Z-scores. The level of confidence C is the area under the standard normal curve between the critical values, negative ZC and positive ZC. Critical values are values that separate sample statistics, like P hat, that are probable from sample statistics that are improbable or unusual. We have some popular level of confidence and also their ZC or critical value. If the level of confidence is 90%, the critical value is 1.645. If the level of confidence is 95%, the critical value is 1.96. If the critical value is 99%, if the level of confidence is 99%, its critical value is 2.575. Let me show you how to use a calculator to basically calculate this level of confidence in other cases, other scenarios. So let me pull up my calculate84 and show you how to use your calculate84 and basically construct everything from scratch. So in your calculator, here you have level of confidence, which is given as 90%. What are you going to do? You're going to go to second and go to vars and then find inverse norm. In the inverse norm, you need to enter 3 different pieces of information. you need to enter area, comma, mean, comma, standard deviation. What is the area? The area is not 90%. The area is 5% to the left. Calculator only has the inverse norm for the area on the left-hand side. So this total area is 90%. 10% divided by 2 is 5%. So we need to enter 5%. 0.05. Use comma to separate that from the mean. The mean of the z-score is always 0, so enter 0. The standard deviation of the standard normal distribution is always 1, so enter 1, and then enter. So as you can see, I get the exact same negative number on the left-hand side. The positive one is 1.645, which is located on the right-hand side, and you get 1.645. So that's how you calculate your critical value. Again, you need to go to second, click on vars, and find inverse norm. In the inverse norm, since it's the larger area is 90%, 1 minus 90% is 10%, 10% divided by 2 is this yellow area here, which is 5%. So we need to enter 5%, 0.05, put comma, mean is going to be 0 because it's standard normal distribution with standard deviation 1. Hit enter and you get the exact same number on the left-hand side, which is your critical value, separating the probable part from improbable, unusual parts. Okay, after finding the critical value, we need to move on to next step. In the next step, we're going to basically construct our confidence interval. How do we do that? First, we need to find the margin of error. Given a level of confidence like C, the margin of error E, which is sometimes called the maximum error of estimate or error tolerance, is the greatest possible distance between the point estimate and the value of the parameter it is estimating. How do we find margin of error? So, after finding the margin of error, I'll show you the formula. A C confidence interval for a population proportion P is P hat minus E, P hat plus E as the limit to the left to the right. You're going to say that, hey, the population parameter is bounded between these two numbers. The margin of error is ZC, the critical value that you found, multiplied by square root of P hat, Q hat, divided by N. Very good. The probability that the confidence interval contains P is C, assuming that the estimation process is repeated large number of times. Okay, we went over all the guidelines. Let's take a look at a couple of examples. In this example, we have a survey of 1,000 US teens. 372 said that they own smartphones. Question says, find point estimate for the population proportion of all US teens who own smartphones. Of course, this data are very old. Nowadays, everybody has a smartphone. So N is equal to 1,000. We have 1,000 people participating in this survey. X is the number of successes, the number of people who said yes, 372. Remember the formula for P hat. P hat is X divided by N. So divide X by N and you get 0.372 or 37.2% of teenagers said yes, we have a smartphone. So the point estimate for the population proportion of US teens who own a smartphone is 37.2%. Okay, but is this a good representative for population? Probably we can say yes, but we need more information. We can take other samples. the first sample, the second sample, the third sample from the population. But are they going to give me the exact same percent? Probably not. So we need to build a confidence interval. In the same survey of 1,000 US teens, 372 said yes. We want to construct a 95% confidence interval for population proportion of US teens who own smartphones. Let us begin, everybody. P hat is 0.372. This is your point estimate that we calculated. 372 divided by 1,000 is 0.372. The proportion of failure is 1 minus 372, 0.372, which gives you 0.628. Well, since n times p hat and n times q hat are large enough, it meets the normality. Now you can move on to the next step and calculate ZC, which is your critical value. Again, to calculate critical value, you can easily use your calculator. Let me show you how to use your calculator. Let me share the screen so you can see both calculator and also the question here. We're going to go to second vars and find inverse norm. Since you have 95% confidence interval, 95% out of 100 gives you 5%. 5% divided by 2 gives you 0.025. So the area on the left-hand side is 0.025. Put comma. Mean of the distribution must be 0, comma, with standard deviation, which must be equal to 1 because it's a standard normal distribution. So as you can see, you have a negative number on the left-hand side. The positive critical value that you're going to use is 1.96. So let us go back to the question itself. We found our ZC, or the critical value. Now we are ready to calculate the margin of error. The margin of error has a formula. We know that we have to multiply our ZC that we calculated here by the square root of p hat q hat over n. So you have 1.96 multiplied by the square root of p hat times q hat over 1,000. Remember that p hat is 372 over 1,000, or 0.372. Q hat is 1 minus p hat, which is 0.628. If you punch everything into your calculator, it gives you approximately about 3%. Okay, this is the distance. This is the margin of error. Now let us go to the next page and find the left and the right endpoint and find the 95% confidence interval. On the left-hand side, you have p hat minus margin of error. P hat is 0.372. Margin of error is 3%. On the right-hand side, you have p hat plus margin of error, which is 0.372 plus 3%. Well, you get 0.342 on the left and 0.42 on the right. So you can say that, hey, I am 95% confident that the population proportion of US teens who own a smartphone is a number in between these two. This is the proportion, 34.2% to 40.2% of US teens own a smartphone. I'm not sure which number it is, but I'm 95% confident about that. That is going to be a number in between these two. One of these numbers is the population proportion of US teens who own a cell phone, but I'm not sure exactly which number is that. But it gives me enough confidence about this value. Now, how do I use my calculator to find the confidence interval. In order to use your calculator, let us pull up the calculator. We are using calculate84, the same calculator that you have using in your class. So take a look. Here, I'm going to go to stat. So this is the function that I'm clicking. I'm going to stat, and then I'm clicking on tests. So from stat, you click on tests. You have different tests here. Z-test, T-test, 2 sample Z-test, 2 sample T-test, 1 proportion Z-test, 2 proportion Z-test, Z-interval, T-interval, 2 sample Z-interval, 2 sample T-interval. You need 1 proportion Z-interval. This is the one that you're looking for. So we clicked on stat, we clicked on tests, and we need to click on 1 proportion Z-interval. Okay, so let's see what do we have here. What is my X? The number of people who said yes on a cell phone was 372. Out of how many? Out of 1,000 people that we surveyed. What is the confidence level? It is 95%, 0.95. So let us do the calculation. Here we go. As you can see, you have the exact same numbers. On the left-hand side, you have 0.372, 0.342, 0.342. On the right-hand side, you have 0.4019, which rounds up to 0.42, which is this number just right here. So you can always use your calculator to find the confidence interval. This is the algebra behind it, and this is how you use a calculator. So in this case, your X and N are given. In the next example, X is missing. So we're going to calculate X separately. Let us go back to our slides and take a look at the next example for you. So in this question, the figure at the right side is from a survey of 498 US adults. So we know how many people participated in the survey. Question says construct a 99% confidence interval for the population proportion of people who think teenagers are more dangerous drivers. Very good. So let us look at our page and see what information are given to us. Who are the more dangerous drivers? Out of 498 people, 71% of them said teenagers. 25% of them said people over 65. 4% says, hey, we don't have any opinion, we don't know. So from the picture, we know P hat is equal to 71%. That is given to us. P hat, or the proportion of successes, or the proportion of people who said teenagers are more dangerous drivers, is given in this picture to us, 71%. So you can easily calculate Q hat, which is 1 minus 71%, or 0.29. Now, using these values and the value that N is equal to 498, ZC, the critical value, is going to be 2.575. You can easily calculate the margin of error using the formula. E is equal to ZC, which is 2.575 times square root of P hat Q hat over N. P hat is given in this question to us. Q hat is 0.29. So if you punch everything into your calculator, ZC square root, what do you get? You get basically about 5%. So the distance or the margin of error is just 5%. Now let us find the left and right endpoints and form the 99% confidence interval. P hat minus E is about 71% minus the margin of error. P hat is 71% or 0.71. E, or the margin of error, is about 5%. This is your left endpoint. On the right-hand side, you have p hat plus E. P hat is 71% plus 0.052. Let us do a little bit of algebra. On the left side, we get 0.658. On the right, we get 0.762. What's the meaning of that? It means that the proportion of the population who think teenagers are more dangerous drivers is a number range here. I don't know which one is it, but I'm sure, I'm 99% sure, I'm 99% confident that it's a number in between these two numbers. So I can write with 99% confidence, you can say that the population proportion of US adults who think that teenagers are the more dangerous drivers is in between 65.8% and 76.2%. So now the question is, how do I use my calculator to make sure I have everything right? So let us go to our calculator and show you how to enter this information into your calculator, given that X is not given to you. So take a look. When I use my calculator for confidence interval, I'm clicking on stat, I'm clicking on tests, and I need to go further down to find one proportion Z test. One proportion Z test. So when I click on that, let me erase the previous information entered here. This says, hey, you need to have your X, you need to have your N, you need to have your confidence level. Well, I don't know what X is, all right? I only know P hat. P hat is 71%, but I can do a little bit of algebra. 71% can be multiplied by the total number of people who participated in this survey, am I right? So let us do the multiplication. You just need to multiply 71%, 0.71 times 498 to get X. So let us do the algebra. 0.71 times 498, which gives me about 353 or 354. So 354. And how many people participated in that survey? 498. Confidence level, 99%. Let us do the calculation. Well, compare these values with the value that you calculated in algebra. The left endpoint is 0.658. You have 0.658. The right endpoint is 0.762. You almost have the similar number, 0.763, which is very close to that number. So either use a calculator to verify your answer, or make sure when you're following algebra, you enter everything correctly into your calculator. Another important question is when we are, for example, finding a confidence interval for proportion, how many people we should include in our survey? This is a super important question given that you are near the selecting president, and we see in the news that that candidate is more popular based on the poll, based on the survey. But the question is, how many people they actually surveyed? We want to find any minimum sample size to estimate P, given a C confidence level and a margin of error E, the minimum sample size N needed to estimate the population proportion P is denoted by N equals to P hat Q hat times ZC divided by N to power 2. But the question is, what if I don't know the preliminary information like P hat and Q hat? If P hat and Q hat are not given to you, you have to use 50%. Let's take a look at one example here. You are running a political campaign and wish to estimate with 95% confidence the population proportion of registered voters who will vote for your candidate. Your estimate must be accurate within 3% of population proportion. And question says, find the minimum sample size needed when no preliminary estimate is available. Very good. Since we don't have basic information like p hat and q hat, we must assume they are 50%. So since you don't have any preliminary estimate of p hat, use 50% of chance of success and 50% of chance of failure. Since you have 95% confidence level, critical value is 1.96 and the margin of error is 3%. Usually students get confused, what is this 3%? This 3% says, hey, your estimate must be accurate. It means that it must be within 3% of distance of population proportion. So basically, your margin of error is given to you. When you are calculating the critical value, we are looking at the confidence level, which is 95% here. Very good. So remember that if you have 95% level of confidence, the critical value is 1.96. Now let us punch everything into our calculator. The formula says you have p hat times q hat times zc divided by e to power 2. P hat is 50%, q hat is 50%, critical value is 1.96, margin of error is 3%, raise them to power 2. You get an approximation of 1067.11. So since n is decimal, round it up to the nearest whole number. So you need to ask at least 1068 people so you can basically construct a confidence interval with 95% confidence. So when you're reading the news and they say, hey, this candidate is more popular than the other candidate, you should be asking, okay, how many people you ask? Was your sample a random sample? This is the important part because usually it takes time to ask people about their opinion. The randomness is very important. So asking 1068 people to get a basic confidence interval requires a lot of work.